My name is Tyler Dirksen. Been on the chat with you guys all day, but you can see me in the flesh here. And I'm actually doing this broadcast from Winnipeg, and it's pretty cold outside, but at least we don't have that many storms or earthquakes, so I think we're doing good so far. So what I'm going to be talking to you about today is the building applications with the IaaS and platform as a service, or infrastructure as a service and platform as a service kind of combined. So we've been hearing a lot about infrastructure as a service, and it's kind of the new thing with Windows Azure right now because it was just released in the kind of over the summer. And platform as a service and cloud services have been around for a while. But how do we actually connect the two, and why do we care about connecting the two? So why do we need to mix the models? So we're hearing a lot about the benefits of each of the models. What would be the benefit of actually combining them together? So the main benefit of combining them all together is that you actually can incorporate a lot of the stateful portions of your applications with a lot of the scalability that goes along with the stateless portions of your applications. And now what I'm also going to talk about is what kind of on-ramp or what kind of practice could you use to get your existing applications to the cloud. And like Jonathan was mentioning in the previous session, the infrastructure as a service, or one of the previous sessions anyway, the infrastructure as a service is very much easier to migrate your applications, because in lots of cases it can be kind of a lift and shift type of mentality where you can get your applications running in Windows Azure, even if they were Linux based or using some other types of platforms. Now, that may be the case, but the platform as a service is a lot better as far as packageability and scalability as well. So you can kind of start with kind of a lift and shift and then migrate your portions of your applications slowly. And I'll go into some of the practices in regards to that. But there are a lot of benefits to using platform as a service. And because Azure provides both infrastructure and platform, you can get a really rich application out of kind of both experiences. So just like we were talking about in the previous talk, this is kind of the Windows Azure service model where you actually have kind of a cloud service that provides you a public endpoint and a load balancer and a lot of other fun stuff. You have web roles and worker roles happening here. And the same really goes for virtual machines as well. So virtual machines can run under cloud services too, and that's essentially how you get your public endpoint for your virtual machine. So they're actually quite similar to web and worker roles. In fact, if you actually dug into some of the results of PowerShell and everything like that, you might find that the actual role for a virtual machine is called a persistent VM role. So it actually kind of fits into the same structure as a regular cloud service role. It kind of runs on top of the kind of cloud service base platform. So let's go into some of the different application patterns that you can use when you are migrating your applications to the cloud and when you're using both infrastructure as a service and cloud as a service. So the first one that I want to talk about is actually communicating through the virtual IP or through the load balancer for the applications. So in this case, what we're really looking at is kind of externalizing or making the portions of your application into a service. So in this case, we actually have kind of a web role at the top and the SQL Server persistent VM at the bottom. People make external requests through port 80. And what will essentially happen is the cloud service will actually go out into and in through the load balancer of the SQL Server and actually make SQL requests through the load balancer. So you would technically have two different services, and it makes it very flexible as far as your SQL Server, your SQL data can be used by more than one service. It kind of externalizes the SQL endpoint for use. So there are some strengths with that. It's very simple. It's very simplistic. It's separated in that you have kind of one service endpoint for your cloud services and then one service endpoint for your data. For the Windows Azure web roles or the stateless roles, you can still do virtual IP swapping, and which is kind of a feature of it's kind of a feature of the platform as a service where you can kind of control your updates with the virtual IP and the load balancer. It's a lot easier to test as well. And the last portion is kind of one that I wanted to talk about a little bit more, which is that if you were to kind of scale this out and you actually had more than one product using the same set of SQL data, you could start kind of duplicating. You don't necessarily have to create different SQL instances and syncing them up and different things like that. You can worry about kind of one SQL Server farm, let's say, service, and start accessing that SQL Server from a variety of different other services. Or you can put in a kind of a web data endpoint in front of the SQL Server as well, and start dealing with that. And I'll talk about a little bit more about that structure in a little bit here. But you could see the weaknesses of this structure because you are going out and in through another load balancer, so there is some latency hit with that, and it is far less secure. You can't expect to just say, I'm going to spin up a new SQL Server and put it out on port 1433 and everything will just be fine. Well, you have to worry about permissions. You have to worry about firewall rules. You should be using SSL when you're accessing the SQL Server. And this endpoint isn't just an endpoint for the local cloud services. It's actually a public endpoint. So you can actually get to this from basically anywhere, which can be an issue. So for this kind of structure, it's actually best to consider the data as a service and consider the security of that data as a service. And that's what I was talking about, like kind of putting a web front end in front of it as well. And as well, one of the weaknesses of this is that it is using the virtual machines, obviously, and so you actually have a management overhead with using this SQL Server. We were discussing in the chat earlier about how much benefit there is actually using SQL Azure, which is kind of managed, scaled, made available through another team, another kind of service, and you're just consuming that service, right? There is a huge amount of value in doing that. And with this particular architecture, you have your own SQL Server instance, you're reducing a lot of that value because the Windows Azure team and SQL Azure team has taken into account a lot of the security concerns that you would have to now take into account again here for this SQL Server service, essentially. So how would you actually set up something like this? So essentially you would treat it like two different services. You'd set up one and then the other. So the first four, like deploy the virtual machines, customize the VMs using a remote desktop. So, in initializing the SQL instance and everything like that. Configuring your endpoints, right? So 2001 through 1433 and things like that. And configuring your firewall as well. You can do that through RDP. And so once you've actually set up your SQL instance, you actually want to run through that SQL instance through its paces. So that would be the force point there, which is local dev/test, where you can either using an emulator or SQL Server Management Studio or different things like that. You can kind of, because you can connect to this from anywhere, you can connect to it from your on-premise and say, well, does this database work? And then after you've verified that this database worked, and even using your local emulator for your web roles and different things like that, you can connect to the database. You'd have higher latency, obviously, but you can verify that it works. You can take those web roles and worker roles and deploy them to the service, and then you should have a functioning application. So let's go on to kind of the next possibility as far as deploying some of these together. And this is getting into the more interesting set, where in this one here, you actually are combining the cloud service, the cloud service and the virtual machine cloud service into the same virtual network. So this would be like Contoso VNet, and you actually are affiliating the Contoso VNet to an affinity group, and then the front end Windows Azure web role is actually connected to the same affinity group, which actually connects the background networks together. So in this way, you have your own network that you're dealing with, and you're not going outside the network, and you don't have an external endpoint for your data services. And so, but you still have two separate services to deal with. So let's see. There's a lot of kind of fun that happens as far as getting this set up. One of the things that isn't really clear with this particular thing, because we have that front end subnet there with 10.0.0.16, is that you don't actually control the IP addresses, the internal IP addresses that are assigned to your web and worker roles, right? So accessing the web and worker roles from the kind of stateful network becomes more difficult because you don't really know exactly where they are. However, if you create subnets for the SQL servers and the SQL mirror kind of main endpoints, you can easily either query the DNS server, the Active Directory, and find out where those pieces are and communicate to your SQL server from the Windows Azure web roles, which is probably what you would really want to do. Now, the strengths of this one is that you still have two separate components. So you actually have the Windows Azure Platform Cloud Services that you can VIP swap and do a lot of the other cloud service implementations with. And then, but you still have the kind of connectivity to your SQL mirrors and your Active Directory and everything like that can support your data access without having to go out of this internal network, right? So you're gaining a lot of security over the previous option for this particular one. And one of the strengths that's not really listed here is that you can, start adding more cloud services to this affinity group and this virtual network. So if you had like 3 applications that you're running in the cloud, or you're actually communicating to your on-premise, which I'm going to go to in a second, you can do that with this because the virtual network is very kind of flexible in that way. So the secret sauce kind of with this piece here is that the virtual network is in an affinity group that is the same affinity group as the cloud service that you're running, and that kind of connects the networks together. Now, the weaknesses of this is that let's see, the setup and provisioning of this is very complex because you are now incorporating a VNet, and you're putting Active Directory likely on the VNet, and you're doing putting the SQL instances on the virtual network, and so you have to kind of figure out which different subnets they're going to go on, which IP addresses they're going to be assigned, and different things like that. You have to use your own DNS server, because when you're in the same cloud service, as John was talking about in infrastructure as a service previously, when you're in the same cloud service and you're not in a virtual network, the cloud service provides the addressing capability. So you can actually say, I want SQL 01, right? And that is the name of your virtual machine. The DNS server provided to your other virtual machines in the same cloud service know each other and know the names of all the virtual machines, so you don't need DNS. However, when you start putting something in a VNet, now you actually need a DNS. So you should have all these machines connected to that Active Directory and use the Active Directory DNS to do the name resolution and stuff like that. So it adds a lot of complexity to your environment, but it could be a required complexity, and it's a different kind of complexity than the previous security concerns that we were talking about with the previous setup. So with the VNet connected, how do you actually do local testing? Because the previous one, you could actually connect to the SQL endpoint from your local machine and do local testing. But with this one, it becomes a little more difficult. So I still want to kind of talk to this point. So here, I'll just snap this for a second. So you can see at the top there, I have a little bit of a change. So you can see that the Contosa VNet actually is in my affinity group. And like I said, that's the kind of secret piece that makes this all kind of work together. So let's see. From your dev fabric, what you actually want to do is temporarily open up the SQL port, right? So that you actually are mimicking the similar kind of scenario from the previous one that we had talked about. And you can verify that the web role running on your developer fabric will actually communicate to the SQL and the SQL mirror and everything like that through port 1433. And you can do this based off of kind of a developer configuration set. So when you actually switch from the kind of developer side to the production, you are going to be changing your configurations. And so this type of testing scenario is not really the best because you're not actually duplicating a production environment in this case. You're kind of connecting using a different means just because you are outside of the machine. Now, if you actually wanted to go the kind of the last mile and say, I want to connect to this as if I were in this virtual network, well, having a VPN tunnel using the local connections will give you that access. So when you are using a VPN tunnel in your local network, your on-premise network is actually part of this Windows Azure network. Now you're actually connected to the SQL and the Active Directory in the exact same way that your cloud service will be connected to the Active Directory. And the VPN tunnel could only be used for this particular testing scenario, or it could also be used to do some Active Directory DNS syncing and different things like that as well. Or you could even have your DNS and Active Directory server on premises also. So there are different options like that for the VPN tunnel, but it's very useful in this particular case to actually do some testing in your application on your local developer fabric and connecting to your SQL server as if it were in the same network, just like it will be when you're going to the cloud. So what are the deployment steps of this kind of structure here? So the first two are probably the most difficult, especially the VNet design VNet, because some of the things that I found anyway when you're kind of getting into doing the VNet design is that you kind of have to figure out exactly what you're going to be doing beforehand and where your DNS servers will be located and different things like that, because it's hard to change the virtual network once you have machines on it. You actually have to take all the machines down or turn them off or whatever. Actually, not even turn them off. You have to remove them, which you can do using the PowerShell scripts and stuff like that. But you definitely have to take them down. It does require some downtime in order to kind of do those things, to do those maintenance things. So designing the virtual network up front can be a little more difficult, but it's something that you kind of have to think of beforehand to eliminate downtime later on fixing it. So deploying the SQL mirror and the Active Directory VMs, customizing those VMs, and then doing kind of a local dev and test. So you can either do this using the public endpoints as we talked about, exposing 1433 or another port. You can make it a huge high port number if you wanted to hide the fact that it's SQL and different things like that, because you can map external ports to other internal ports and different things. So let's see, and then you can deploy the service and kind of hope and pray that it actually will work the same way as when you were doing the testing. And if you are doing the VPN connected testing, it likely will be the same because you are addressing the SQL box in the exact same way there. And then make production ready is a very crucial last step here, especially if you've opened public ports. You're going to have to close them. You're going to have to change the port numbers or do otherwise. So let's see. I'm just going to switch back to kind of my video and talk about something that wasn't really discussed here. So what you could actually do, it's not really talked about a lot because the virtual networks is there and they're a lot more capable with the VPN tunnels and stuff like that. But one of the things that is available to you is the SQL Connect, or not SQL Connect, sorry, Azure Connect, which is kind of a machine-to-machine connection, which you can set up in kind of a development scenario against your SQL Azure machine. So you can actually set up Azure Connect on the SQL box and then set up Azure Connect on your local dev machine and actually try and connect those two together through a machine-to-machine network in order to do your testing. So the Azure Connect will kind of put the machines into the same network temporarily. Now, it makes it a little more difficult if you're using Active Directory or other machines, because you have to now set up Azure Connect on those machines or what have you. So this is probably just to test some subset of the functionality. Again, the VPN connected piece is probably the best way to test the integration between these two. But there are other options. Is kind of what I wanted to highlight. So I'm just going to switch back here. So now I'm going to go into the last portion, which has kind of been dubbed the mixed mode. So like I was mentioning before, the persistent VM roles are just roles. They're roles just like a web role and a worker role. It's just they're a different type, and they actually can communicate with storage a different way. And there's a lot of, there's a lot of infrastructure involved with that. But at the end of the day, it's actually kind of the same thing. It's still a cloud service. So um, the mixed mode is actually putting web and worker roles together with virtual machines in the same cloud application or the same cloud service. So this is a very simplistic approach. It has high connectivity, and you're actually using the IDNS or the DNS servers, so you can actually, because your worker roles are named and because your virtual machines are named, they can actually communicate with each other very easily using the DNS system there. The weaknesses here is that when you start putting persistent VM roles into your cloud service, you actually lose the ability to perform a VIP swap. So a VIP swap is when you have a public endpoint that your load balancer is listening on that routes information to your production environment and the servers in your production environment. However, with the VIP swap, what you can do is you can set up a staging environment that's sitting beside kind of your production environment, and which has a different public endpoint, and you can verify that the staging environment is up and running, and then swap them. So the virtual IP will actually connect to the new environment and stop routing connections to the old environment. So it's a very, very powerful tool when you're actually doing deployments, and you can actually do zero downtime deployments when used properly. But unfortunately, with this mixed mode, you'll actually lose the ability to do a VIP swap because of the complexity of the virtual machine role. You can't, with the virtual machines now, you can't actually perform VIP swaps. There's no staging virtual machines. It's all just always production. Now, the other problem with this is that it is going to be available in the fall release, and that's just something like this is a very good solution as far as having stateful virtual machines and stateful portions of your application sitting beside web and worker roles that are stateless. And it's definitely a kind of application mode that the product teams have taken into account. So it's soon to be released, this capability of doing this. So it's not really out yet, but kind of keep this on your radar as one of the options. Just before I go to the next piece, I want to talk about this. To me, when just kind of my kind of commentary on this particular solution, from a deployment scenario or an application management scenario, this seems a little too simple. I'd like to be a little bit more careful, or let's say, about how my environments are built. I like the kind of concept of virtual networks and connecting my own on-premise to the virtual networks. And if you're using a lot of Azure services, then you'll probably have a mechanism for doing those kinds of deployments, or having those different environments, or even have a piece of hardware sitting in your infrastructure in order to create virtual network connections. And so you'll be utilizing services that you already have. This particular solution, it seems to be more akin to kind of maybe one-off or smaller types of implementations where it's really good for those situations where you want to deploy something like WordPress or Drupal or .NET Nuke, or you have kind of a web portion that can be scaled, but those are supported by a data tier like MySQL or otherwise that isn't provided by, well, MySQL kind of is, let's say PostgreSQL or something like that, that you actually need a persistent VM in order to do. So if you had a Drupal environment with a PostgreSQL database and you wanted to kind of migrate that to Windows Azure and wanted to make this Drupal web role very scalable, you could actually make a package for the Drupal environment and make that highly scalable, but then put the PostgreSQL bits onto a virtual machine and do it that way. So like, this is a very powerful, very easy mode, this mixed mode, because of its simplicity, but it doesn't seem to be kind of really big production system, in kind of my opinion anyway. But we'll keep an eye on it for the long run, and make sure to kind of keep taking a look at the developer connection and other blogs just to see kind of when this stuff becomes available. Now let's get down to the numbers. So the two kind of main portions here are the DIP or the VIP. So the DIP is the kind of dynamic IP, the internal IP connections between the 10 dot or 192 dot, depending on what you set up, connections. And the VIP is the virtual IP connection. So you're actually going out to the load balancer. So when you're actually connecting from an internal network to an internal cloud service, you're looking at a round trip of 0.29 milliseconds for a DIP to DIP. And that's mainly because you're not actually going through a load balancer in this particular case. So, but you're not actually sacrificing a ton of time. You know, it's not, well, it's just more than double the amount of time there, but it's still 0.88 milliseconds, even VIP to VIP. So as long as you're actually deploying your applications into the same data center, because you know you do have the ability to deploy your applications into multiple different data centers. But if you keep them in the same kind of affinity group, but you can still use the load balancer in that way too. And that brings me to another point, a kind of another benefit of using the VIP portion or the kind of VIP mode of communicating between these applications is that when you're actually making a request to the SQL or the other persistent service, you can actually go through a load balancer and have that connection load balanced. Which can be very helpful as far as scalability is concerned. So I'm going to actually go into the next portion, which is just how to actually kind of bring your application up to these modes here. So in order to kind of take advantage of platform as a service, what I would recommend is especially is, well, I'll just talk about why you would want to take advantage of platform as a service compared to infrastructure as a service. So the main thing is the elasticity of the main thing, as far as I'm concerned, is the elasticity of what you are putting together. So when you have a virtual machine, and you can probably genericize that virtual machine and deploy another copy of it very fast, but likely you'll actually have to go through the kind of provisioning or configuration steps of this virtual machine before it actually becomes online and is available for use, which can take some time. Now with platform as a service, you actually have all that configuration and setup in a package, right, that gets deployed to the virtual machine. And the best case scenario of deploying the package is that everything is just online. So that makes it very, very elastic in that you can just change a number rather than actually having to deploy an entirely new virtual machine, probably connecting through remote desktop and configuring it and different things like that. But there are other things as well. One of the main ones to be talking about is that the web and worker roles have their operating system patched continuously, and you don't actually have to do the OS patching yourself, which is a huge benefit. And even the operating system local firewalls configured for you when you start opening ports and different things like that, which is something you'll have to do on your virtual machine yourself. And that's something that I've definitely come across when I'm setting up a virtual machine as a step that I've forgotten is setting up the external port firewall rules and different things like that. So how would you actually go about doing the migration? So what I've got here is just kind of a kind of Windows Azure. You can't really see that in the perspective mode, so I'll just switch back. So what I have here is a Windows Azure based implementation that already has a bunch of virtual machines in a virtual network, right? So I've got 4 web tiers, 2 app tiers, and 2 data tiers, and an Active Directory sitting there in my Windows Azure virtual network, and they're all in infrastructure as a service and virtual machines. So what I can do first is start taking down the web tiers and putting in web roles instead of the web tier portion. So my external requests are coming into the web roles, and that first kind of defense or whatever, I wouldn't say defense, the first line into your application is probably the one that you'd want to scale the most. So it's definitely the most worthwhile portion of your application that you want to make available, and as far as the scalability is concerned. Now, the second one obviously is the app tier, the logic tier of your application, which you can start converting to worker roles instead of actually app tier machines, and you can even do some scaling or auto scaling of those worker roles depending on how much traffic is coming in through the web roles. And then last but not least, your data tier, which you have on persistent VMs, can be taken out and replaced with Azure SQL DB or Azure Database or SQL Azure, whatever you want to call it, the actual data as a service portion that is available through Windows Azure, which now, once you've actually migrated all this stuff, we still kind of have an Active Directory sitting there, but it's possible that we never need that Active Directory again. We don't really need to manage the virtual machines because we have services, the cloud services actually taking care of the web roles and worker roles and virtual machines. And plus we actually have the Windows Azure, SQL Azure happening there, and that's not under Active Directory. So you can actually take out kind of the Active Directory mode here. So just to kind of wrap up a little bit, and then we can get into the QA after the break, but just to kind of wrap up, there are a variety of different options for connecting different things like web services and worker roles and web roles to virtual machines. I didn't really talk about websites very much, but there are some more options there. And now, the main reason that you'd want to do this is that you have portions of your environment, either they store data or they are more archaic applications like Complex and Active Directory that kind of require persistent data storage, and you need to kind of build them up in SQL into Windows Azure using persistent VM roles. And we went over some of the capabilities or some of the, practices of putting your applications onto the cloud. So like I had mentioned, we're actually going to take a quick break at this point, but then after the break, we're actually going to go into a quick Q&A discussion with Jonathan and myself, and then if you have any questions about this, you can put them in the chat during the break, or we'll be online to answer questions from the chat in a moment. So I hope you gained a little bit of info from this discussion about the migrating applications to the cloud using the platform as a service and infrastructure as a service together, and it got your brain thinking a little bit. And so just keep those questions coming, and we'll be online in a little bit.